Hey guys, in this video we're going to learn how to multiply a monomial times a polynomial. Now in the last video we looked at how to do a monomial times a monomial, so that's the most simple polynomial times the most simple polynomial. What we're going to look at now is what happens if we have the most simple polynomial times could be as complicated as we want. And the good news is you already know how to do it. So our objective is to distribute a monomial through a polynomial, and that right there should clue you in on how we do this. This is literally the distributive property. So for instance, had I not had this dressed in a lesson about polynomial multiplication, if you would have looked at this, you would have said, oh, this is the distributive property. That's negative 6x minus 15. You know how to do that. We're multiplying there and there. Let's kind of break that down. Let's write this out. Let's make it more complicated looking than it necessarily has to be. I'm doing negative 3 times 2x, and then I'm going to add to this negative 3 times 5. So negative 3 times 2x, negative 3 times 5, negative 3 times 2x is negative 6x. Negative 3 times 5 is negative 15, so plus a negative, that's just going to be minus 15. But all I did was multiply that negative 3 by everything in there. Now comes the part where we realize that we've been doing something more complicated all along. Negative 3 is a polynomial. It's a monomial. That monomial right there. 2x plus 5 is a polynomial. That is a linear binomial. So guess what? I just multiplied a monomial times a polynomial. I just distribute. It is literally that simple. So what we're going to see, I'm going to show you 5 examples of how you might do this, and I'm going to turn you loose on your own. So without further ado, let's look at example 1. Simplify the expression and write your answer in standard form. Don't let that part mess you up where you forget to do that. So here I have a monomial, 3n squared, times a polynomial, 2n minus 6, but really when I come down to it, it's the distributive property. So I'm going to distribute this and do 3n squared times 2n, and then I'm going to do 3n squared times negative 6. And now this is just a monomial times a monomial. We know how to do this. 3 times 2 is 6. N squared times n, well, I add the exponents. 2 plus 1 is going to be n cubed. 3 times negative 6 is negative 18. N squared times, well, nothing. Is just going to be n squared. Now I have my polynomial. I try and put that in standard form. Turns out it already is. The highest degree term is first. And so there we go. I've multiplied those polynomials. So this is a cubic binomial, and all I did was distribute those throughout. Simple as that. So for another example, we can make these as arbitrarily ugly as we want. Here I'm distributing a 4th degree term, or a 4th degree monomial, through this binomial, but it's still the same thing, 6y to the 4th times 7y squared, and then negative 6y to the 4th times negative 1. Notice that sign came with it, and the sign of the 1 came with it as well. I wrote that as a negative 1. Negative 6 times 7 would be negative 42y, and then I add my exponents. 4 plus 2 is 6. So when I multiply those together, I get negative 42y to the 6th. Over here, negative 6 times negative 1 is positive 6. Notice I'm using the plus as the symbol between the terms. And then y to the 4th times, well, I don't have anything else. Just stays y to the 4th. Write it in standard form. Turns out it already is. Isn't that nice? So this 6th degree binomial is my answer. Ooh, got fancy here. What's different about this one? It doesn't matter because we still just distribute. So I'm going to distribute the 3x squared through that second polynomial. So I multiply it times the 2x, and then I do 3x squared. Now I'm going to multiply it by the x squared that's inside the parentheses, and then 3x squared, and I'm going to multiply that by -7. And so now it's just 3 separate examples of monomial multiplication. 3 times 2 is 6. X squared times x is x cubed. Don't forget to add in that 1. Over here, 3 times, there's nothing there, so it's a 1. 3 times 1 would be 3. X squared times x squared, x to the 4th. And then 3 times -7 is -21, x squared. I do have to write this in standard form, and this one is not. So finally I get to add something in there, and I apologize, this should be a plus sign right there. So now what I'm going to do is rearrange this so that the 3x to the 4th comes first, x to the 3rd the next highest, and so on and so forth. And there we go. That quartic trinomial is my answer in standard form. So for a 4th example, now I've got a negative monomial, a coefficient that's negative on that monomial, distributed through a trinomial, and it is, again, friends, nothing new. The exact same story, just repeated over and over and over again. And that's really, you'll see that the rest of polynomial multiplication is pretty much just these same ideas repeated over and over again. So here we go, -6 times 8 is -48. And now I get into the 4th. -6 times, this is a -1 right here, be careful. -6 times -1 is +6 into the, add those together, and I get 5th. -6 times 4 is -24 into the 3rd. I do need to write these in standard form, so I'm going to move this quintic term, the one that is of degree 5, out to the front, and then my 4th degree term, and finally my 3rd degree term, and there's my answer. Hopefully by this point you're getting bored out of your mind. Let's look at one final example. Oh, just kidding! Sold myself too much there. So instead of 5 examples, just 4. My apologies. So there you go. This is about as ugly as this gets. I could make this polynomial here as long as I want. If I want a 6-term polynomial, I can do it. We just have to repeat that distributive property over and over and over again until we get our final answer. So there you go. Multiplying a monomial times a polynomial is just the distributive property. Nothing more fancy than that. Practice. Make sure you get good at this. Do it correctly, then worry about getting it fast. Best of luck, my friends.